Hello everyone, myself Bandgar S.S. working as assistant professor at Department of Physics, KTHM College, NASA. In this video, we have to cover S.Y.B.Sc paper 2nd semester 3 subject of instrumentation. In this video, we have to going to talk on a first chapter fundamental of measurement, and we have to going to discuss the subtopic of standard and calibration methods of measurement system. First topic is the fundamental of measurement. So starting with a standard measurements. So in 1960, one international committee, that is the System International Units, established a set of standard, that is the standard measurements of a measurement quantity, like as a length, mass, time, temperature, electric current, luminous intensity, and amount of system. So these the measuring quantity are measured or defined by the some units or standards, that is the System International Units or standard. So length has the meter, mass has the kilogram, time has the seconds, temperature has a Kelvin, electric current has ampere, luminous intensity has a candela, and amount of substance is the mole. So these are the measuring quantity has some definite some definite SI units. So next one is the types of standard. So types of standard is depend on their functions and application. So these are the four standards. First one is the international standard, second one is the primary standard, third one is the secondary standard, and fourth one is the working standard. So these are the four types of the standards of measurements of systems. Next one is the starting with a international standard. A International Bureau of Weights and Measure at Sevres and France maintained the standards of measurement system. These standards are not available to an ordinary user for the purpose of day-to-day comparison. So these are the not easily available to the general people or user for their day-to-day life. So some three main standards. These three are the main basic measurement quantity. First one is the kilogram, that is the one is the kg. In 1987, the mass standard is established of a Pacific platinum iridium alloy is an unusually stable alloy which kept in a cylinder at sub-zero class. So you will get the mass standard. Second one is the second. It is defined as the 9-19-26-31-770 times the period of vibration of radiation from the cesium-133 atom. So that is the number of times of period of vibration of radiation from the cesium-133 atom. You define the seconds of measurement of time. In earlier up to 1960, the seconds were defined by 1/16, 1/16, and 1/20. So it is the one first bracket is the 1/16 is the for minute, the second is the 1/16 for hour, and last bracket is the 1/24. It is the 24 hours for 1 day. So of a mean solar day. So in before 1960, we have to calculate the second like that. Next is the length. So this is the third measurement quantity. Basic measurement quantity is the length. So it is measured by the or standard by a meter. It is defined as the distance traveled by a light in vacuum during a time of 1/299,792,458 seconds. So that is the speed of light. So you can get the distance or length traveled by a light. During in 1960, the length of meter was defined by distance between two lines on a Pacific platinum iridium bar stored under a control condition in parts. So After a or during a 1960, the length of meter was defined by the distance between a two lines or specific platinum iridium bar. Two bars are generated in a platinum iridium bar stored in a trans control condition, so that decides the length of the meter, or it defines the standard of the length. Next one is the primary standards. So primary standards are constructed and designed and calibrated by national laboratory and similar organization using guidelines of International Bureau of Weights and Measures. So primary standards are constructed, designed and calibrated by various national laboratory and organization using a guidelines of International Bureau of Weights and Measures. So all these devices under a secondary and working standards are calibrated and certified by a primary. So next types of standards are certified or under control by the primary standards. So these standards are also not available to the ordinary user for the calibration and certification of working standards. So whatever working standards you are available, easily available to the general people or general user, but that primary standards is not easily available for a ordinary user or general user for calibration and certification. Working standards. Next type of standard is the secondary standard. The main objective of secondary standard is to calibrate and certify the working standards against the primary standards. So I have already told the standards are dependent on the other standards. So same as the secondary standards calibrate and certify the working standard against the primary standard. So whatever working standards of general user or the ordinary people or ordinary user, so that is the calibrated and certified by a secondary standards. It is maintained by a industrial measurement laboratory. So these are the secondary standards are maintained by a industrial measurement laboratory. It is freely available to the ordinary user, so it is the very easily available to the general people. It is also known as the calibration standard. So it is the calibrated, or it is the some trial and error, or it is the error finding standard or calibrated standard. Next one is the working standard. It is also known as the workshop measuring standard. It is known as the workshop measuring standard. The general laboratory industrial measurements are calibrated by using working standard against primary and secondary standards. So these are the standards is very useful to the general people, general user or ordinary user. So it is the easily available to the anyone or any general user. These working standards are widely and freely available to the ordinary user. So it is the easily available to the ordinary user. So example as the standard register for register measurement, standard inductor, that is the use for inductance measurement. Now next topic is the calibration. So why require a calibration? So calibration, it gives the specific, that is the very definite value of the measurement system, or get the very definite output of the measurement system, or it gives the error free output of the measurement system, and it gives the desired output or without error free output. So that's why we have to require a calibration technique. So this is a quantitative comparison of basic values of input and output of an instrument with a corresponding reference standard. So whatever value of input and output of the instrument which compared with the reference standard, that is the known as the calibration. It is the estimation of uncertainty between the values indicated by measuring instrument and true value of the input. So it is the gives it clear the uncertainty between the values indicated by or generated by a measurement system or true value of the input. So that is the clear or clarification of the between two values. It offers requires operating accuracy of the device or instrument. So which gives the very specific output, very error-free output. So it gives the very operating accuracy of the device or instrument. If the device response is linear, then a single point calibration is sufficient. If your device input output relation is the linear relation, it is the directly proportional relation between them. So there we have to use a only single point calibration. If there is no linear relation between their input and output of the measurement system, then set of point of calibration required. So there we doesn't use a single point calibration. So we require to take a set of point of calibration to get the desired result, definite result or specific result. So calibration is classified by the 5 ways. First one is the primary calibration, second one is the secondary calibration, third one is the direct calibration with known input source, fourth one is the indirect calibration, fifth one is the routine calibration. So these are the calibration classification. It also depend on the what type of the standards are used there in a calibration. So starting with primary calibration, when system or device is calibrated against primary standards, then that process is known as primary calibration. So when the device or system is calibrated against the primary standard, that process is known as the primary. In this calibration gives extremely accurate and absolute value. So primary calibration will get the very exactly accurate or absolute value of this device is employed as a secondary calibration system when primary calibration system. After a primary calibration system done, then it gives or that output is given to the secondary calibration system. Example, standard register, standard sales. So these are the examples of the primary calibration. Second one is the secondary calibration. The secondary calibration is a device is used for further calibrating another device for lesser accuracy. So that is the second calibration for used for to the further calibration of with compared with another device, but there is some accuracy is the minimum. The second calibration device are practical calibration sources which widely used in industry and general laboratory practice. So these devices are used mostly in industry and laboratory purposes. The secondary calibration examples like as a standard cell may be used for calibrating a voltmeter and ammeter with a suitable circuit. And second one is the microphone and accelerometer may be used as for calibrating frequency response or accuracy. So these two devices are used for calibrating the frequency response and accuracy of the measurement system. Next one is the third type is the direct calibration with known input source. So when we know the what is the input source of the measurement system, you can do the directly calibration of the measurement system. The directly calibration with non-input source is a general of the same order of accuracy as a primary calibration. Therefore, devices that are calibrated directly are used as a secondary calibrated device. So, when we do the direct calibration with inputs with non-input source, that time when we know the input source, so it is the act as a same accuracy as a primary calibration, and it is directly given to the or used as a secondary calibration device. So means it's directly given to the secondary calibration techniques or secondary calibration device. It gives the accuracy of similar to primary calibration, hence directly calibrated for secondary calibration used as a system can also be. So it is the directly calibrated by a secondary calibration device. Consider one example, a flow meter. A turbine flow meter may be directly calibrated using primary measurements such as weighing a certain amount of water in a tank, recording a time taken for this quantity of water flow through the meter. Subsequently, the flow of meter may be used for secondary calibration of the other flow metering device such as orifice meter or Venturi meter. So here measure a flow of meter directly by a secondary calibration of the orifice meter or Venturi meter. Next one type is the indirect calibration. Indirect calibration is based on the equivalence of two different devices that can be employed for measuring a certain physical quantity. So when we compare of two different devices for some physical quantity, so we can employ the indirect calibration of that system. So it is possible to carry out indirect calibration. Predict the performance of one meter is based on the study of the other. Hence, a small meter can be used to determine discharge coefficient of large. So you can predict the any calibration technique of large meter by using a small meter. Consider one example, a turbine flow meter. The requirement of dynamic similarity between two geometrical similar flow meters is obtained through the maintenance of equal Reynolds number of standards. So you have to know when we use the Reynolds number. So when we define the two same quantity equally, so that time we have to use a Reynolds number. So here we have to define the two similar flow of the turbine flow. So the meter to be calibrated respectively. For such a condition, the discharge coefficient of two meters is directly compared. So you can calculate for the one flow meter, turbine meter, and similar for the another flow meter. So you can directly compare it to the second turbine flow using a indirect calibration. Next one is the routine calibration. This is the last type of the calibration technique. This calibration is the procedure of periodically checking the accuracy and proper functioning of the instruments with standards are known as accurately reproducible. So that routine calibration, it is the one procedure of calibration technique. It is the periodically or one rule of procedure checking the accuracy and proper functioning of the measurement system instruments with standards. That is the which gives the very precisely or accurately reproducible output. That is the known as the routine calibration. It is the periodic checking the accuracy and proper functioning of instrument with known instrument. So it is the continuously checking the accuracy and proper functioning of the instrument with their standards. The entire procedure is normally laid down for making various adjustments, checking the scale readings, etc., which conforms to the accepted norms. So whatever norms is decided, which confirms when the various adjustment and checking the scales are normally laid down for a making of the history of the entire process. So following these are the steps we have to perform the calibration procedure. So these following some usual steps taken in the calibration procedure. First one is the visual inspection of the instrument for removing physical defects. First one, using a visual inspection, whatever defects or whatever errors in a physical physical manner of instrument. Second one is the checking the instrument for proper installation in accordance with manufacturing specification. First, check up all the initial states of the instrument. Next one is the zero settings of the indicator. First, set all the indicators in a initial level or zero. Fourth one is leveling of the device, which require the precaution, and also check the levels of the device or instrument for their safety purpose. And fifth one is the recommended operational test to detect the major defects. So take some initial test or operational test to detect any major defects or minor defects, whatever will be generated at the output. So you have to test by some operational test.